extra fluff or anything like that. So path of the packet, our source in this case is PC1. Okay, so we're going to track all the way from PC1, our source, all the way to our destination, which is the DHCP server. Because the goal here is PC1 needs to get an IP address. Okay, so we need to follow how it would get a IP address. Okay, so we're gonna layer 1, layer 2, layer 3, and basically what this exercise is going to do is I'm going to ask you, right, based on the scenario, right, what's the source MAC address, the destination MAC address, the source IP, and the destination IP whenever it leaves a device, whether that be a PC, whether that be a switch, whether that be a router, or if the destination is sending that packet back to the source, right? So we may take pauses here and there, talk about, spanning tree, routing, et cetera, but that's the core of it. So we'll get started, of course. I'm going to piggyback back and forth between Kiara and Jerquan. So Kiara, you're first, right? So PC1 right now, again, it doesn't have an IP address. It has a MAC address, right? So for it to get an IP address, right, it needs to go ahead and find the DHCP server, right? So to do that, right, it needs to go ahead and send, a broadcast message out, right? I'll give you that little hint. Send a broadcast message out that says, where is my DHCP server? Okay? And it should get a response back, right, from the router in this case. It's going to say, hey, I know where the DHCP server is located. It's located over there, right? Here's the information. Send your request to me. I'll take care of it, right? With all that being said, what does the packet look like once PC1 has all that information from router 1 or R1? What is going to be the source MAC, the destination MAC, the source IP, and the destination IP from PC1 to R1?
So the source will be right now the 0.0.0.
Okay.
No,
so
no,
PC1's.
Source MAC is the 0. Yeah, that one.
This one? Okay.
Yeah.
All right. So PC1's MAC. Gotcha. All right.
Destination
What about
MAC,
the
the destination MAC is the MAC address of R1.
Okay.
The source.
Like this. There we go. All right. Destination MAC is going to be R1. Okay. Okay. Now, what's that source IP?
The zeros of PC1, since we don't have a IP address.
Okay. And what's that destination?
The 6.4.2.0/24. I want to say.
Say it again.
The 6.4.2.0/24.
6.4.2/0/24. Okay. So, all right. So tell me, for all four of your answers, tell me the reason why you stated that to be your answers.
I feel like I always get this wrong when I'm testing, but I want to say because right now I got the source MAC just because that's coming from PC1. Destination.
Okay.
That's the router that we're trying to reach right now. So the router to get the DHCP request from that server, and then the source IP address. I want to say it's the 0, but I feel like I always get that wrong when I am trying to study for it, or like I want to say because we don't have an IP address that's the reason. And then a destination IP is I figure out, I think we got this through the request of talking to the router, I want to say, that we know
Mm-hmm.
their IP address. Yeah.
Mm-hmm.
I'm uncertain though right now because I'm like, again, this
It's
is where
all
I'm
good.
testing,
It's all
but I'm like, I'm
it's all
unsure, but I
it's
believe in
it's all
my
good. So it's all
answers.
good. This is good. This is good.
Okay.
So this is a benchmark. So this is, again, guys, say your answers with confidence is perfectly fine. So you got 3 out of the 4 correct. Okay. Source MAC,
Okay.
absolutely. Layer 2, right? It's coming from PC1. That's the MAC address that frame is sourcing from, right? On this broadcast domain. Destination MAC, R1. It needs to be sent there, right? Source
Okay.
IP, PC1. What's the IP of it now? 0.0.0.0. That's the IP. We don't have nothing at that place right now, so that's the IP, right? So that's why we're searching for the DHCP server, right?
Right.
The destination IP, you were close, right? So it's this function, and I'm not sure if you heard it, called DHCP relay, right? You guys can write this down or tell me repeat it or what have you. So what this does, right, and what I've done in my lab, right, or in any environment you probably see maybe configured sometimes, is that R1, right, it'll have a function to where if it hears DHCP requests on a broadcast domain that it administers, for this example, off of gigabit 0/1, right, in the 192.168.0.0 network, right, if it hears DHCP requests on it, but it knows the DHCP server is somewhere else, right, it's on a totally different network, it can get that request, right, get those DHCP broadcast messages or discover messages and say, hey, I'll go ahead and take it from here, right, and I'll go ahead and send it to the DHCP server for you, right, and then when it comes back, I'll go ahead and send it right back to you. Here's the reason being that the correct part that you said, Kiara, right, 0.0.0.0, we can't send that out to the World Wide Web.
Okay.
Right, because that's an unknown host. If we send that out to the web, it may get to the destination, but it's gonna say, hey, bro, we don't know how to send it back. We don't know where this goes. That's why we need the DHCP relay in place so that it can come back to R1. R1 will say, this is a DHCP relay request. We'll go ahead and send this back to PC1 based on its MAC address. That make sense?
Mm-hmm.
Okay. So again, so going to R1 is the destination is 172.16.1.25 because R1 responded to that broadcast message saying, hey, the DHCP server sits here. Here's the IP address. So now it's going to send it to R1. Okay. So
Okay.
write this down. This is the first packet. All right. So this is the first way it's getting sent out. So we're going to go to R1. Right. I'm going to erase all this. Okay. There we go. Okay. All right. So Jerquan, you're up next. So now R1 has it, right? It needs to send it to our destination, the DHCP server, right? Just like Kiara did. What's that source MAC address, destination MAC address, source IP, and destination IP, and why?
Okay.
And again, just to let you know, R1 on this subnet, its identifier, so it's 6.4.2.1 because it's R1, and R2 would be 6.4.2.1. I'm sorry, 6.4.2.2 because it's R2. Just to let you know. So
Okay.
I didn't put it up there, so that's my mistake. But just wanted to let you know, so you can think about it and let me know what that source and destination and for the MAC address and the IP is.
Okay. So right now it sounds like we've already had our first packet from what Kiara just explained.
Okay.
Subnet that we're on, the packet is between PC1 and router 1, and now it needs to go to the next network, which has
Okay.
R2. And this source MAC address is going to be R1's MAC address, which is
Okay.
5000030000.
Okay.
And the destination MAC address is going to be R2's MAC address because it's jumping from one subnet to the next network, or the
Okay.
next portion of the network. The
Okay.
source IP address would be 6.4.2.1.
Okay.
And the destination MAC address, I feel like in this moment, not I feel like, I know in this moment that the router is going to send a broadcast frame out on the next network so it can find the DHCP server. And the source, the destination IP is going to be the IP address of the DHCP server, because that's the server it's looking to do a handshake with and acquaint itself. So 172.1.6.1.25.
Okay. Okay. All right. And thank you for telling me your why while you gave me your answers. So, great job. Great job. Here's where I'll correct you. And you did right. The only thing is, I think the function of DHCP relay is not prevalent to you just yet. So with DHCP relay, I'll explain it again. Again, it's taking those local DHCP requests and sending it to an external server, right? It's going to send it based on its IP address, right? But, right, which IP address is R1 going to use, right? If I send it using the source IP of 6.4. whatever, how does R1 know where to give it back to? R1 doesn't know.
It wouldn't know.
Because it's being sent back to a broadcast domain or a local area network that it didn't originate from. So it's going to say, oh, I don't know why you send this here. This PC, wherever the MAC address sits at, it doesn't exist here. So what DHCP relay does, it says, cool, I got your request, PC1. I'm going to use my IP address of the inside interface, 192.168.0.1, and send this request on your behalf. The reason being is that whenever I'm sending it across networks, other networks know where to send it back to via layer 3. So then when it's coming back and it gets to me, layer 2, I can send it back to PC1 because I can only communicate to PC1 via layer 2 because it doesn't have an IP address just yet. Does that make sense?
Yeah, that makes sense. It sounds like the IP address isn't saved into the table yet, so it doesn't recognize the path or the location of it.
Exactly, right? So 0.0.0.0 is what it translates to is, a couple of things. All hosts or unknown hosts. So it means everybody, right? So it's like, let's say me, you, and Kiara are at a taco bar, right? Somebody walks in, right, drunk as hell, and says, I'll beat everybody ass in here, right? That person has a 0.0.0.0, right? They're telling us, they're telling everybody, right? But they're saying it like a router, like it's like PC1, 0.0.0.0. They're mentioning everybody. So they didn't specifically say Kiara, Jerquan, or Dave. They said, bro, everybody can get it. You know what I'm saying? But that ain't gonna work. So we need to make sure we direct it, make sure we make sure it looks good and what have you, right? So the source IP in this case, right? 192.168.0.1, right? Cool. All right. So it's looking good. It's looking good, right? So now it gets to R2, right? R2 says, cool, I got your request. I'll go ahead and take care of it from here. So we're going to go back to Kiara. So this should be fairly easy for you. So let me know how it looks. what's the source MAC, destination, IP, and all that.
Source will be the 50. Yeah, the MAC address of R2.
Okay.
Destination MAC will be the MAC address of the switch.
Okay.
Two.
All right.
The source IP. I'm trying to going to the DHCP relay would be destination or source of. It'll be the IP of R2.
Okay. What's that address? 6.4.2.1 or 172.16.1.2?
Oh no, 6.4.2.1.
Okay. 6.4.2.2. Okay. And destination?
Destination IP will be the 0.0.0. No, I believe. Yeah.
So that's the destination IP.
I'm looking at the DHCP relay notes I just took from you. I believe so, because that's who we
Okay.
need to speak to. That's
Okay.
that's the request that needs to. I want to say yes.
It's okay. It's all right. It's all right. So let's talk through this, right? So at layer 2, you're golden. You're golden. You're good, right? Let's talk about layer 3 though, right? The IP, right?
Mhm.
So the DHCP relay is only configured on R1. I never told you it was configured on R2.
Okay.
Okay. So that IP is going to be 192.168.0.1 because remember what we just talked about. It needs to know, the server needs to know where to send it back to. That's why we're using the DHCP relay. Okay. All right. So that's why it needs to be that it needs to be 192.168.0.1 because it needs to know how to get back to that subnet. Right.
Okay. Yes.
So the golden rule, and I want you guys, both of y'all, to write this down, anybody that's listening. Without DHCP relay, right? Let's take that shit out of there. A packet at layer 3 rarely changes. Layer 2, it's always going to change. But at layer 3, it rarely changes. Okay? The source IP will always be the source IP. The destination IP will always be the destination IP. Even with that, it'll put a whole new layer 3 column on top of the original, but it'll always be what it needs to. Okay? So, golden rule. Source and destination IP will never change at layer 3. At layer 2, the MAC address will always change. Okay? So, the packet is at R2, right? Right? And so we identified our source. Our destination IP is 0.0.0.0, right, Kiara? But it hasn't gotten to the DHCP server yet.
Uh-huh.
So basically what this is telling me is that we're sending, we're sending that packet, right? We're sending that packet to nobody if we do 0.0.0.0. We still have to send it to that DHCP server. You know what I mean? So that's not going to change. So we're going to go ahead and make sure we know where to send it to. So that destination is still going to be the same, DHCP server, 172.16.1.25. Okay? Because what this telling us is, great, right? R2 received that packet from R1. The MAC address is going to change, but R2 needs to know where to send it back to, and the DHCP server needs to know where to send it back to. Okay? But R2 needs to know where to send it to from a layer 2 standpoint. Make sense?
Yes.
Okay. All right, cool. So we got that. So we got our packet. our packet is now at switch 2. So we're almost home. We're almost at the DHCP server. But, and here's a question I'm going to ask you and Jerquan, and you guys can answer it first. How much have you guys dove into spanning tree?
I would say the basics of it, like I can understand it. Not saying
Mhm.
I applied it to the life of a packet, but I can understand it from a basic level of like setting it up, etc.
Okay.
Same. I understand it from a concept level, what it's used for, but I haven't applied it to anything yet.
Okay. No worries. All right. So again, this is a benchmark. So we'll see how much you know. Okay. So Jerquan, you're up. So we have a layer 2 switch network right here. Okay. Before frames, right? Because that's what they're called at layer 2. They're not called packets. Before frames can be forwarded, right? We need to make sure we have a loop-free network, right? So using spanning tree, right? Before we do that, we need to make sure we identify a couple of things: who our root bridge, our port roles, and our port states. Okay. So looking at this, right? Let me get this out of here. Let me create a new text box. Cool. So looking at this, right? Look at all the MAC addresses for each switch. Which one is our root switch and why?
Give me 1 second. Say that switch 3 is our root switch because that's the switch that's closest in the closest proximity to the DHCP server.
Switch.
Say it again.
Switch 3.
Switch 1.
Hold on, Joakim. So Jerquan, you said switch 3.
Yes, because it's the closest proximity to the DHCP server.
Okay. Kiara, what about you? Thoughts?
And we're at switch 3, correct?
Switch 3 is the root. Is that what you're saying?
Yeah.
Okay. All right. So real quick about spanning tree, right? So with the root bridge, the root switch election, right? It's going to elect the root switch within its switch topology, whoever has the lowest bridge ID, right? Zamir, I don't know if you still have that link I sent you. If you can drop it in here, let me see if I have it. Give me 1 second.
Okay, I'm gonna check because
So-
I looked on my phone and all my messages gone from Slack, so I'm gonna check on my computer.
It's all right, brother. It's all good. I just found it. Hold on. There you go. So, right? So whenever switches, they connect with each other, they're going to talk with each other, right? They're going to send messages called BPDUs, bridge protocol data units, right? And they're going to send their bridge IDs to each other, right? They're going to talk to each other. They're going to say, hey, I'm Diddy. Hey, I'm Jay-Z. Hey, I'm Beyonce. Hey, I'm Kanye, right? It's gonna talk amongst each other and see who has the best value in the room, right? From a layer 2 standpoint and a switch standpoint, it's going to say, hey, who has the lowest bridge ID, right? So lowest meaning, and you guys can read that article I sent you. It's a good page as well if you're studying for your CCNA. It's looking at the priority field, right? And we'll take a look at that. I'll start at one of these switches, right? And the 6-byte system ID, right? And that's typically the MAC address of the switch, right? So let's say, right? Let's say I didn't add any VLANs, right? We didn't add the VLANs here. What I'm looking for is the switch with the lowest MAC address, okay? To give you guys a hint, number 1 is the lowest number. 10 is a high number. After, and unfortunately with hexadecimal, it goes up to 9, then it's gonna go ahead and switch to letters, A, B, C, etc. Okay? So with that being said, Jerquan, Kiara, look at this again. Look for the switch with reading from left to right with the lowest number. Okay? And that's your root switch. And then you guys can tell me which one is the root switch.
Would that be switch 1?
Which one?
Whenever you guys are ready.
Which one?
Oh,
Okay.
switch 1.
Which one? Okay. Okay. All right. So where's the packet is here. Okay. So it's behind R2. This switch topology is switch 2, switch 3, switch 6, switch 4, switch 5. Switch 1 is on a different network.
Okay.
Okay. So within this network, who's the root?
Switch 2.
Switch 2 is the root.
Yes.
Perfect. Exactamundo. That's it. Root switch. Okay. All right. So here's what I'm going to do. I'm not going to dwell on this so much. I want you guys to really look in deep spanning tree. We're gonna have session 2, and we're just going to focus on spanning tree. And I'm going to see whenever Zamir has free time, so we can pull Zamir in because he did a great job on our last spanning tree. I don't want to take up you guys Sunday. All right. Let's say I'm not going to give you guys the answers, but the packet gets to the destination. Okay, it gets to the DHCP server, it gets its DHCP requests, right? It goes all throughout this network, and it needs to get back to R2, right? So it goes ahead, right? It goes ahead and it needs to send that back to PC1 entirely, right? Where is the DHCP server? What's that source and destination IP address and MAC address for the DHCP server when it's sending that packet back? And this one is going to be on Kiara.
So we're at the DHCP server and we're going back to PC1.
Mm-hmm.
Okay. So the source MAC would be the MAC address of the DHCP server.
Okay. Got it. Okay. Destination map.
I know you said we were going to skip it, but with STP, does the root having the root switches, does that have to do with anything with the destination MAC?
It does, but all I want you to answer is where the DHCP server is sending the packet next.
Okay.
Okay.
Destination MAC, I want to say, is the MAC address of switch 1.
Okay. Which one, right?
Yes.
Okay. Get that for you. Okay. And the source IP?
172.16.1.25.
Okay.
Destination IP is 172.16.1.0.
Okay. All right. So let's look over this, right? So at layer 3, you're golden. Okay. Layer 2, the source, excellent. Destination, though, not so much. Okay. So let me give you guys another golden rule for your studies. Okay. And I think it'll help out with the drawing. Give me 1 second. Let me get my handy dandy notebook. Okay. All right. Am I good? Yeah, I'm good. Okay. All right. You guys see what I just drew? So I drew those, right, on the router or what have you, right, just to show you guys something, right? So each interface on a router is a broadcast domain, right? That's the big word for it, right? Each interface on a router is a local area network. It defines a local area network. On R2, that network is 172.16.1.0/24. The flip side of R2, another network, 6.4.2.0. On R1, there's another network, 192.168.0.0/24. Different interfaces, different networks. Okay. Okay. Routers operate at layer 3. Okay. So if packets or frames try to cross layer 3, they can, but it doesn't keep its layer 2 value. Okay. Layer 3 is going to cross it, right? Because that's what its job. But after it crosses a layer 3 boundary, it's not going to keep its layer 2 value. What does that mean? So if the DHCP server, its goal is to send a packet back to PC1, right? And it's going to send it, like Kiara said, she was correct, to the destination IP on this network, local area network, 172.16.1.0, it's going to go ahead and send it, right? It's going to send it to router 2, but it's going to stop at router 2. In a sense, she was correct, but not entirely correct, because it's not the end goal is not R2. The end goal is PC1, but we can't use PC1's address. So what are we using? The DHCP relay address, the address of R1, right? Source and destination, anything at layer 3, whenever the destination finally receives wherever it receives and needs to communicate back to the source, they're going to flip roles. Now the DHCP server is the source, and now the destination is wherever it came from. Never changes. Remember, layer 3 doesn't change. Okay? Going back to layer 2, right? She said the source was the DHCP server. Absolutely correct. Destination MAC, said it's switch 1, right? So back to my rule and looking at my lines, right? Layer 2 cannot cross layer 3 boundaries. Remember that. So DHCP server is not even going to know about the MAC address of switch 1. It's going to know about the MAC address of all these switches, and it's going to know the MAC address of R2. What the DHCP server is going to do, and I'm sure you guys worked on Windows a lot, the DHCP server is going to say, I know the source and destination IP. I know I need to send it to R1 so it can send it to PC1, right? It's going to look in its routing table on its PC and say, hey, I need to send this to R2. I have the MAC address of R2. I just need to send, and R2 being my gateway, via layer 2, I just need to send it to it. I just need to send it to R2. That's it. Okay? Right? Because any device, right? Any device that's connected on the same layer 2 network, they're going to know about each other. As long as they're same VLAN, there's nothing limiting them from communicating with each other, they're going to know about each other. In this case, the DHCP server, its gateway is R2. It knows where to send packets whenever it doesn't live on this subnet. It's going to send to R2. So in that case, right, let me go ahead and erase all this, clear all drawings. That MAC address, right, coming from the DHCP server, going to PC1, the destination MAC is going to be R2. The switches are going to see it, and we'll talk about spanning trees soon. Switches are going to see it. They can say, hey, I know where this is at. This is R2. Hey, send it to this, send it to that, and get it going, right? Again, the destination, Kiara, you weren't wrong, right? You weren't fully wrong. The gateway on the DHCP server is saying, hey, R2. But as far as from a packet transit standpoint, it needs to send it back to PC1 because that's where the original request came from. So we're going to say, hey, we're going to send it back to R1. Does that make sense?
Yes.
Cool. All right. So R2 has it. Perfect. Jerquan, you already know what it is. You're up next. How's the packet look now from R2 to R1?
Okay, so right now the packet is at R2 and it's traveling to R1. So source MAC address will be R2's MAC address.
Okay.
The
All right.
destination MAC address will be R1's MAC address.
Why?
Because the packet is going from R2's segment of the network to R1's segment of the network where PC1 is identified and logged.
So so R2 couldn't send it directly to PC1 using its PC1's MAC address?
Well, now that you say it, it could, because the first time PC1 sent the packet broadcast to find the DHCP server, it already crossed R2's routing table, and MAC address should be already saved in the routing table. So yes, it could.
Incorrect. All right. So I said that to slip you up a little bit, okay? So remember, my golden rule that I just shared with you. Layer 2 doesn't cross layer 3 boundaries. If it's a layer 3 device, like a router, firewall, or what have you, right? Sending something layer 2 that exists beyond this boundary, right? If I'm trying to send something from R2, right, to PC1 with its MAC address, that's not going to work, right? Because there's a layer 3 boundary right here that's protecting this network. So R2 is never going to know about PC1.
So is PC1's MAC address only saved in R1's MAC address table?
Yep, and it's only behind R1. R1 will not share the MAC address because R1 is not a layer 2 device. It is a layer 3 device. That make sense?
That makes sense.
It ain't its job to mitigate layer 2. That's what switches are for. You see how when we were back on the other network with the DHCP server, the DHCP server knew from layer 2 to send it to R2, and the switches just, hey, I know where you need to go. Go ahead and go here. But DHCP server, trying to send something to PC1 with a destination MAC of PC1's MAC address, it will never work because there's a layer 3 boundary right there. Does that make sense?
Now that you explain it to me, it does, yeah.
Okay. We'll dig deeper after we get past spanning tree. I'll go over routing concepts, but I just want you to drill this into your mind right now. Layer 2 cannot cross layer 3 boundaries. Once it does, the layer 2 values are going to change. Okay? And this is all an effort to make sure routing and switching properly happens. All right? So, with that being said, we finally got our packet back to R1, right? Finally got it back to R1, right? And I'll go ahead and tell you guys this part because DHCP relays a little bit of a new thing. R1 gets it. It says, hey, all right, I got the packet. I'm going to go ahead and take off right? Me has the destination, right? I'm going to take off the layer 3 section, and I'm going to send PC1 the information via layer 2, and that's it. That's it. The destination MAC is going to be PC1. The destination MAC will not be the switch because, again, they all live in the same local area network. So R1 is just going to send that right down to PC1. It can talk to it. Okay? And that's the path of the packet. Questions, feedback, thoughts?
The portion about the layer 3 and the layer 2 boundaries,
Mm-hmm.
I understand what you're saying, but I'm not sure in my studies like where I skipped over that, or where I can like just kind of drill that concept into my head, because what you're saying makes complete sense, but it sounds like that's a portion of the study that I may have glanced over or didn't catch.
Which is okay, because remember, this is a benchmark, right? So this is what a benchmark is meant to do. So you know, just like working out or running, it's meant to you go back and take a look at stuff. So if you read anything about routing concepts in your CCNA and switching concepts, I am for sure they will touch on that. If not, that page that I sent you, the study-ccna.com, real good guys over there. They will show you. They have a section that's actually called the life of a packet, and they will show you how that works. You will also learn about switching and routing and what have you, and how that path works. So review that. I can also send you some videos too that'll go over that, and it'll make sense. So then when we go over this a second time, and if you guys want to commit to it, we can review this either next week or 2 weeks from now, if you guys need some time. But I would really like to give you guys a second go at it.
I would love to review it in weeks if that fits into everyone's schedule.
Yeah. Okay, that works. So I'll go ahead and set a time, and of course we'll speak amongst the Signal group, and you guys can let me know, because again, Jerquan and Kiara, this is for you guys. But yes, next time we're gonna go back over the spanning tree part. So just remember, we'll go back over the spanning tree part, and then I'll explain in detail, Jerquan, to help, because I know you'll do you and Kiara will do your studies, but in detail what's happening, right? Inside the router and the switch whenever it's doing those routing and switching decisions. Okay.
Okay.
Cool.
All right, folks. All right. Well, happy Sunday. You guys have a great day, and I'll go ahead and post the link shortly so you guys can take a look at it and view it. Give me 1 second. I got one of my good friends joining. He'll be able to give you guys some good advice. Give me 1 second.
Okay.
His name is in the chat. It's Claude, but we call him Mace Windu. So give me 1 second for him to join.
Y'all did good. Y'all did good.
Thank you. I was going to ask David too, like from my studies, how much do we grasp? Because I feel like 80%, like I came in knowing 80% of, I believe, like basic, but now I feel not discouraged, but I know like it's some things kind of like what Jerquan said, like the layer 2 and layer 3 boundaries. I'm kind of like trying to get that in my head now.
I feel like overall too, it's a lot of information. And so, moments like this just let you know where you are and give you the awareness of how much to learn. Where you go. Like I told him earlier on Jerquan that when he first asked me about Spanish protocol, I didn't know it at all. And I had to go learn it, or I didn't really know my Linux commands, and I had to go and learn different stuff. And so, because it's a safe space for learning and we all learning, it just shows you moments like that. Trust me, I've had some, trust me, we've all been in the hot seat in this group, so I totally understand.
Listen, I get paid at my job to take down networks. I still know how I still have a job, but essence, right? But just same sentiments as Zamir. Nobody's perfect. Whatever certification somebody has, I still end up going back and looking at my CCNA studies for fundamentals because you forget, and it takes time to learn, right? So last but not least, my boy Mace Windu, he's on the call. Claude, they just got finished with it. They started their CCNA studies. This is just a benchmark for them. If you can give them any advice, this is for Kiara and Jerquan. They just went through the gauntlet. If you can give them some advice before they come back and do the second session of this, where we're going to go over STP in depth as far as election process or what have you. Any advice for them?
Good morning. Can y'all hear me okay?
Yes.
Yeah, y'all in the right place. I'm sure Zamir done put y'all on game, because yeah, Zamir's come a long ways. He's definitely come a long ways.
Yes, yes, I told him that, Claude.
Yeah. And this is what it's all about. You got to put that work in. I can't stress that enough. You got to put that work in because see, here's the thing, and this is part of let me ask you this, Dave. Is this the other Slack group?
Yeah, the other group I'm part of.
Okay,
yeah.
so I'm going to say this. I'm going to say this. There are times where I would challenge members of our other group, and what some individuals will try to do is they will try to hold me to certain topics at certain levels. And what I try to get them to understand is sometimes you got to live outside the book. Okay. When you go to these jobs, when you go into these interviews, and you get into these real world situations, I'm sorry to tell you this, but the problems that they're going to have are not going to be restricted to what's in the book.
Amen.
So what I do, and some of the other seniors, you may have heard the name Jermaine, what we try to do is expose you to some real world scenarios. Now, don't get me wrong. Understanding the book is paramount. That's foundational stuff, which was what Dave is going through with y'all guys. I advise y'all to go over that stuff, refresh, make cue cards every so often, give it about 10 minutes here and there, read it, just keep it fresh on your minds. Because when you go to work, unfortunately, the scenarios you're going to run into at work are not always going to be that textbook stuff. But understanding the fundamentals will help you get through that real world stuff that I'm talking about. And some of you will see it. Some of you may have already seen it, But like I said, y'all guys are in the right place, giving up some time on a Sunday or a Saturday, And the thing is, you don't always have to cram hours and hours, every day. Or some people will work Monday through Friday and try to get 4 or 5 hours on the weekend. You don't have to do that. All you got to do is expose yourself 10, 15 minutes here and there. The time that you may sit scrolling through Facebook or Twitter or what's the other I don't got those apps, but
yeah,
TikTok,
I know you
everybody got
BlackBerry.
TikTok, not me.
Yeah,
TikTok.
Yeah. The time it takes you to scroll through them 10, 15 minutes is the time that you can take to roll through your spanning tree rolls, to roll through your port states. You see what I'm saying? Just so that you can get familiar with it. So keep doing what y'all doing. I'm sure Dave, I've been rocking with Dave for a minute now. I'm sure he's probably said reach out to him. He probably knows some individuals. He knows some individuals on Quick Dial. Trust me, he knows some individuals on Quick Dial if he needs to pull up some more generals for you to reach out to. Okay. But yeah, by all means, y'all doing wonderful. I know it may seem overwhelming at first. Zamir probably told you about this Gulag. We've all been in it. We've actually done mock interviews in the past to kind of prepare some individuals for what may be out there for certain types of positions. But like I said, just keep at it, stick with Dave, you know, and just keep that book handy, whether it's PDF or if you old fashioned like me to like the actual hardbacks, you know, just keep them books handy, you know. Yeah, that's all I got to say.
I
Mace,
appreciate that so much,
appreciate you.
Clark.
Appreciate you. Mace, if they wanted to get in contact with you, because again, they're part of another group, can they reach out to you like via LinkedIn? I know you have that
Absolutely.
or whatever.
Let me put in the chat. Hold on a second.
Okay.
I do have one question also. So I know today is our benchmark, but I did want to know the website that you put into the chat, the study-ccna.com. Are there small projects or are there like small walkthroughs on just all of these things inside of that website? So I can just pull up Packet Tracer and just walk through it that way?
There's not, but if you pass the benchmark, I'll give you some. You got to get through the benchmark though.
Deal.
This is why this is called the Gulag. Get through the Gulag, I'll give you some labs. Plain and simple.
I appreciate that.
Deal.
No problem. So it looks like Claude went ahead and shared his LinkedIn. Yeah, he shared his LinkedIn. I'll reshare my LinkedIn as well, which I'm sure I think you guys already probably have it. But yeah, you guys go enjoy your Sunday. This will be uploaded shortly. You guys can watch this. Kiara and Jerquan, again, great job. You guys can watch it. Take a look at it. Go play by play, just like the people that play football and basketball do. Go do a play by play, and we'll speak amongst each other to see when you guys want to reschedule that next session. And we'll go from there.
Thank you so much, David.
All right, guys. Happy Sunday. You guys have a great week.
All right, have a good one. Thank you all for
Take
Have a
care.
good one, guys.
all the tips.
Y'all have a
Be
nice
safe.
Enjoy.